Hello everyone, I am Dr. Residual. I welcome you in my YouTube channel. Today in this video, we are going to learn about hydrosphere. You know, hydrosphere is in syllabus of semester 3 of MSc Chemistry. So let us start learning of chapter of hydrosphere. Before that, we should clear our concept related to environment. You know, my friend, environment is the surroundings or conditions in which a person, animal or plant lives or operates. It may be living, biotic, or non-living, abiotic things. It includes physical, chemical, and other natural forces. You know, my friend, environment exerts important role in the healthy living of human being. Humanity's entire life support system depends on the well-being of all the environmental factors. So, my friends, components of environments. We have atmosphere, we have hydrosphere, we have lithosphere. So, I will focus on hydrosphere and biosphere. So, what is the importance of hydrosphere? You know, water is possibly the most important compound on earth. Why? Because it cycles around earth and able to interact with every other sphere like lithosphere, atmosphere, and biosphere. You know, water cycling in the hydrological cycle effectively transports a wide array of both essential and hazardous chemicals. You know, my friend, it can be estimated that there are 1,386 million cubic kilometers of water present on earth, approx, which include water in any form such as liquid and frozen form at different places like groundwater, ocean, lakes and streams. Largest type is of salt water that account for 97.5% of total amount, while fresh water account for only 2.5%. Out of all fresh water, 68.9% is in the form of ice and permanent snow, which forms a cover in the Arctic, the Antarctic, and mountain glacier. 30.8% is in the form of fresh groundwater, and only 0.3% of the fresh water on earth is in easily accessible lakes, reservoirs, and river system. My friend, world water distribution. You can see fresh water and salt water, and then lakes and river, then groundwater, then locked in glacier. This is the percentage. So, the total mass of Earth hydrosphere is about 1.4 into 10 to the power 18 tons, which is approximately about 0.023% of Earth's total mass. At any given specific time, about 20 into 10 to the power 12 tons of the total Earth's hydrosphere is in the form of water vapor. Approximately 71% of Earth's surface, an area of some 361 million square kilometer is covered by ocean. The average salinity of Earth's ocean is about 35 grams of salt per kilogram of seawater. This is the data. Now, chemical composition, which is our target. We are, as a chemist, much more interested in chemical composition. The chemical composition of natural water such as rivers, lakes, seas, wetlands and other is usually classified under the given headlines. Main ions, dissolved gases, biogenous substances, organic substances, microelements and pollutants. What is the main ions? Minerals substances contained in natural water in form of ions, complex ions, undissociated compound and colloids are conventionally subdivided into macro components and micro components. The macro components contain the so-called main ion, which determines water chemical type and account for the bulk of natural water minerals content, which is approximately 95% for fresh water and 99% for highly mineralized waters. The microcomponent comprise substances occurring only under certain conditions or in very small concentration, that is in milligram. Some concentration is occupied by ions of hydrogen, compounds of nitrogens, phosphorus and silicon dissolved in water. The concentration of all minerals present at a specific position is related to two main factors: the abundance of chemical element in the earth crust, the solubility of their compounds. The main anion contained in natural water are chloride, sulphate, bicarbonate and carbonate, and the main cations are calcium, sodium, magnesium and potassium ion. Now, what is the chloride ion? Where it has large migratory ability in connection with the very high solubility of chloride salt of sodium, magnesium and calcium. In presence in water is naturally associated with the process of leaching from minerals such as sylvite, KCl, carnallite, KMgCl and 6 water molecules, bisulfide, MgCl2 6H2O and so on. So chloride ion concentrations may vary from milligram to gram per liter of water. Now sulphate, it contained in all surface water and their content is limited by the presence of calcium ion together with which they form slightly soluble calcium sulphate. So you can see the elemental sulfur house converted into the sulphate by oxidation. So out of many sources of sulphate in water, most common are sedimentary rocks which include gypsum, calcium sulphate and anhydride, inorganic anhydride for the sulfur or sulfur trioxide which is derived from the sulfuric acid. Now water, my friend, enrichment by sulphate takes place both by the process of oxidation of the sulfide which is abundant in the earth crust and the oxidation of hydrogen sulfide which is created during the volcanic eruptions and is present in atmospheric precipitations. The sulfate content of water of rivers and fresh water lakes reaches several tens of milligrams. You can see how this sulfur converted into the sulfate. Now hydrocarbons and carbonate, bicarbonate or carbonate or hydrocarbonate, it occurs in natural water in dynamic equilibrium with carbonic acid in certain quantitative proportion and form a carbonate system of chemical equilibrium connected with pH of water. When the pH of water system is 7 to 8.5, the predominant ion is hydrocarbonate. When the pH is less than 5, the content of the hydrocarbonate ions is close to the zero. So carbonate ion dominate when pH greater than 8. The source of bicarbonate and carbonate are various carbonate rocks such as calcite, dolomite, magnesite, from which dissolutions takes place with the participation of carbon dioxide. Now friends, usually in surface fresh water bicarbonate content does not exceed 250 milligram per liter, while carbonate content can reach grams, even dozens of grams per liter. Now, ions of sodium. The migratory ability of sodium as an element is rather high, as its salt have high solubility. Out of all minerals, sodium ion is third in the concentration. With higher mineralization, the content of sodium rises in water. Having mineralization of some gram per liter, it becomes a dominant ion. High proportion of the sodium ion is balanced by chlorine ion. The source of sodium plus in water are deposited various salts such as rock salt and mineral halide. Now, ion of potassium. Potassium, in terms of the magnitude of its content in the earth crust and the solubility of its compound, is very similar to the sodium. My friend, it occurs in lower concentration in the surface water as it has weak migratory ability. This is due to its active participation in biological process, absorption by living plants and microorganisms. Now, my friends, ion calcium. Calcium are carbonate rocks, limestones, dolomite that are dissolved by carbonic acid content in water. Calcium ion, remember, when the availability of carbon dioxide, which is balanced, is however, the reaction begin to proceed in the reverse direction accompanied by precipitation of carbonate. You have to write this equation. Another source of calcium in natural water is gypsum. Gypsum, calcium sulphate to H2O, is common in sedimentary rock. The calcium ion dominate in the cation composition of low mineralization water or mineralized water. Now, ions of magnesium. The magnesium is less abundant than calcium in the earth crust. It enters surface water as a result of process of chemical weathering and dissolution of dolomite and other rocks. Magnesium ion occurs in all natural water but very seldom dominate. Its concentration in river water range from 1 to 10 of milligram per liter. The biological activity of magnesium as compared with the calcium is weaker, and also the higher solubility of magnesium sulphate and hydrocarbonate as compared to the equivalent compounds of calcium lead to increase of magnesium ion concentration in water. So, ion of hydrogens. Hydrogen ions are always present in water as they rise during the electrolytic dissociation of water itself. The concentration of a hydrogen ion in water solution can be determined by a so-called ionic product of water. So, it follows that the product of the concentration of hydrogen ion and hydroxyl at a temperature of 27 degrees Celsius is always equal to the constant value. So, the water reaction is usually expressed as concentration of hydrogen ions when pH is equal to 7. Water reaction is neutral. If greater than 7 or less than 7, then the reaction shift in the alkaline or acidic direction respectively. So, dissolved gases. This is very important topic. The composition of gases connected with the exchange process between water and atmosphere depends mainly on their content in atmosphere. The term of abundance of gases in the atmosphere, nitrogen, oxygen, argon and carbon dioxide of the composition, and these are the most important determining the composition of natural water. My friends, many processes which takes place in water bodies including biochemical ion needs the presence of oxygen, carbon dioxide, methane, and so very less percentage, hydrogen, sulfide, ammonia, heavy hydrocarbons and nitrogen. The natural process such as volcanic process, degassing of the earth, mantle, supply oxide and dioxide of the carbon, methane, ammonia, hydrogen sulfide, hydrogen chloride, sulfurous gas and other into natural water. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.